Now we need to actually look at some uses of differentiation. One of the big ones, as you'll see, is finding the maximum of a function or the minimum of a function, but there are other things we can do as well. I already mentioned earlier on that we can talk about velocity as being a change in distance over a change in time. So if our distance is x, then our velocity function we can find from taking the derivative of this. So it would be dx by dt. Then the acceleration is the rate of change of the velocity, which means it's the second derivative of the distance function. Or we could also look at it as being the derivative of the velocity function. This takes us back to some earlier work where we looked at equations of straight lines, and the equation of a tangent is given by y minus y1 equals m times x minus x1, and m is the slope. M is what we can find by differentiation. We could rewrite that another way. We could say that y was equal to m times x minus x1 plus y1. Now, in this course, we're not required to know what a normal is. A tangent is tangential to a curve, and a normal is at right angles to it. If we needed to, we would use the rule that says y minus y1 is equal to negative 1 over m times x minus x1. So if we needed to find the equation of the normal, we would use that. But again, m is using the rule that we've just looked at. What we first need to do is we need to find m. So the m is the derivative at that point, so we need to find dy by dx, and the derivative of that is going to be 3x squared over 2, and we're going to find that at x equals negative 1, then, well, we haven't got y either, so we need to find y as well. So we substitute in negative 1, and we find that y is equal to negative 1/2. They tell us that. So now we're going to put all of that information into the rule that we had on the previous slide. So when we put in negative 1, so m is going to be 3 times negative 1 squared over 2, which is just 3 over 2. So y is going to be equal to 3 over 2 x minus 1, which is x plus 1, plus, well, actually, y is negative, so it's going to be plus negative 1/2, which I've now committed to writing. But you would have written it as minus 1/2. Similarly, for the last one, we needed to find m. So m was equal to the derivative, which is equal to negative 5 when x is 3. So we're told that y is equal to a third, so our equation is going to be y minus a third is equal to -5 times x minus 3. And we can leave it like that, or we could. We need to just be a little bit careful when we talk about speed and velocity. Speed is simply a rate of change of distance for a change in time. And my speed of 100 kilometers an hour going forwards is read on my speedometer as the same 100 kilometers an hour if I go backwards. But if we're talking about velocity, velocity does have a direction. Velocity is actually a vector, so we need some idea of direction as well as the speed. Velocity can be thought of as negative, and all that means is that the object is going to the left, or down if the initial one was going up. The acceleration then is the rate at which the velocity is changing. If an object's moving to the left, so it's got negative velocity, and it's accelerating to the right at the same time, then actually, if you think about it, it's slowing down. If an object is moving to the right, so the velocity is positive, and it's accelerating to the left, then again, it's actually slowing down. And similarly, if we've got a positive velocity and a positive acceleration, it's speeding up. And if we've got a negative velocity and a negative acceleration, then it's also speeding up. Now, it's possibly a kind of a good idea to think of this table, and where you've got the velocity and the acceleration having the same signs, then your speed is increasing. If the velocity and the acceleration have different signs, then your speed is decreasing. For this kind of problem, the first thing we need to do is to find the velocity. And the velocity is the derivative of the distance, so it would be 9t squared minus 4t plus 4. And the acceleration function would be the derivative of that, which would be 18t minus 4. Now you're actually asked to find then the velocity when t is 0. So when t is 0, the velocity is 4 meters per second. And the acceleration is put in 0 into 18t minus 4, and it's negative 4 meters per second squared. So the speed is actually decreasing. For the second example, when it's t is equal to 1.5, then the velocity is equal to, now we just need to sub 1.5 into the velocity function, and we get 18.25. And we put again 1.5 into the acceleration function, and we get 18 times 1.5 minus 4, which would give us 23. So the speed is increasing. First thing we need to do is look at the information that we've been given and see if we can come up with our distance function. X is equal to a half gt squared, and we're told what g is. G is 9.8, so it would be 4.9 t squared. Then we need to find the velocity function. It's going to be the derivative of that, so it would be 2 times 4.9, so it would be 9.8 t meters per second. And then you're asked to find the acceleration function, which which is the derivative of that. And look at that, we're back to being 9.8 meters per second squared. Okay, when t is 2, then the velocity is 9.8 times 2, which would be 19.6. And then the acceleration when t is 2 is going to be constant. It's constant acceleration due to gravity, so it's just going to be 9.8 meters per second squared. It's a very common exam question, but one of the tricks in here is to look at your units. The function itself is given in meters and seconds, but you're asked for the answer in kilometers per hour. So all we need to do is we just need to note that 20 meters per second is equal to, how do you convert that? It's 20 times 3.6. So it would be 72 kilometers per hour. So just need to look out for those little things, right? You're given your distance function, so you need to find your velocity function. So your velocity function is going to be the derivative of that, so it'd be 20 minus 10 over 3t. And when the brakes are applied, that's your instant, that's now. So that would be when t is equal to 0. So then velocity is going to be equal to 20. So your initial velocity is 20 meters per second, but you're asked to put that in kilometers per hour. We've already converted that, so it's 72 kilometers per hour. Find the distance the car travels before it stops. The only thing you know when the car stops is that v is equal to 0. So we know an expression for v that says 20 minus 10 over 3t, and that's got to be equal to 0. So we have to solve that, rearrange it, and we will get that t is equal to 6 seconds. Now just think about what the question is asking. It says find the distance that the car travels before it stops. Okay, what we've worked out is an answer of the time it takes to stop. So what we now need to do is take this t equals 6 seconds and put it back in the distance function. So the distance that it travels is going to be 20 times 6 minus 5 over 3 times 6 squared. Push that through your calculator and you get that the answer is 60 meters. So what that says is that if you're traveling at 72 kilometers per hour and you apply the brakes, then you're going to take 60 meters before you stop. It makes no difference whether your velocity is going along a straight line or it's going around a circle. It's still the velocity. And remember from way back, the angular velocity was just called omega. So it's just the same thing. It's just the derivative. So in this case, it would be 18t minus 6t squared. And you're asked to find that when t is 1, so it'd be substituting in t equals 1, and you would get an answer of 12 rads per second. The angular acceleration is just the same, only all you need to remember is you're going around a circle rather than going in a straight line. So the acceleration is just going to be the second derivative, or the derivative of alpha of the omega of the angular velocity. So it would be 18 minus 12t. And you've got to find that when t is 1, so that's going to be equal to 6. And put your units in, be 6 radians per second. Same sort of question again. It doesn't matter that this is a valve going up and down or a slide going up and down. It's still the same thing. You still have to find the velocity, and the velocity is equal to the derivative of your distance function. So the derivative is going to be 5 times 2.2, which is 11, but it'll be negative 11 sine 5 pi t plus 5 times 3.6 is 18 cos 5 pi t. Now here's another trick. It's 30 milliseconds. And the question is given in terms of seconds. So just be careful, 30 milliseconds is equal to 30 times 10 to the negative 3 seconds. So just watch out for that. So now all we need to do is sub in 5 times, that's a 5, times pi times 30 times 10 to the negative 3 plus 18 times cos of 5 times pi times 30 times 10 to the negative 3. All of that, push it through, and it comes out as 34.7 in the units that you've got, which is centimetres per second. But wait, look back at the question. It says find the velocity in meters per second. So we need to now change that to meters per second, which would be 0.347 meters per second.